Alright, welcome to the first video lecture in CS245. In this lecture I'm going to be showing you how to do some basic C++ programming, getting you prepared for Lab 1. So the first thing I'm going to do over here in my terminal is I'm going to change into my projects directory, and then I'm going to create a new directory with makedir called cs245/examples. Then I'm going to change directory into that one. I'm going to put this code on GitHub later so you can see it and follow along. We can see through LSing that there's nothing in that directory yet, and that's because we just created it. Then on the left in Emacs, or whatever editor you will be using, I'm going to open up hello.cpp. Now the first thing I'm going to do is write out a comment. Comments in C++ begin with /*, and then they go until the last time you see a */. Alright, so technically I didn't need to put 2 stars on the first line, but I did anyway. That's how comments look in C++. There are also these other kind of comments, this 2 slashes, and that goes for the rest of the line. So the multi-line comments begin with */* and end with */, and then the 2 front slashes start a single line comment. Alright, so now I included a file IOStream. And that's because I'm going to need access to some printing functions, and I defined this function int main. Alright, now I've defined int main with 2 arguments, int argc and char ** argv. We'll explain a little bit more about these in the future. Alright, so I'm going to compile this, hello.cpp, and I see that now I have 2 files, a.out and hello.cpp. a.out is the name of the file that when I compiled it is the actual executable. I can launch this command echo, and it'll with $? And it'll print the return value. And I can see that's that return value, return 1 from main. So the return value of main will be what's called the status code for the application. So whatever main returns is going to be whatever the status code is. And that's used to indicate on Unix-based systems either failure or success. So by convention, so this is just standard Unix programming convention or basically normal programming convention. If an application returns 0 from main, it signals normal application exit. And a non-zero status or return value for main indicates some sort of failure. So sometimes we'll use 1 for failure, sometimes applications will return other numbers for failure. It's kind of application specific. Alright, so the first thing we want to do is print out a message to the user screen. So to do this, we're going to do std:\cout, and we're going to use these 2 left arrows, and then we're going to write the message we want to print out, in this case hello world, followed by a new line, and that's going to be our command. Alright, so let's go over and compile that again with Clang++, and then we're going to go do hello world. We'll see that printed out to the screen. Alright, so I'm going to make my font size a little bit bigger here. Alright, now this is kind of magic looking. Turns out that std:\cout, so the reason that I had to type this std:\cout is because cout is a function that I'm calling. And it turns out that that function is located within this thing called a namespace. Alright, so this std:\cout means that we are calling the function cout in the namespace std, which is just the C++ standard namespace. And that comes from the standard library, and that library was included by me including this header file IOStream. And so that's what that #include open sort of left arrow bracket IOStream is for. Alright, so a namespace in C++ is something like, it's just a collection of functions and classes and stuff that I put together. And we can in fact create our own namespaces. We'll see how to do that in a few minutes, but a namespace is sort of just like a folder that collects a bunch of functions. So because I might define my own cout function, the standard library wants to be sort of smart by isolating all of its standard library code in this std namespace. Alright, and so because the cout function is in the std namespace, we have to use std:\cout, which then calls the cout function in that namespace. Alright, if I just typed cout right now, the program would not compile. The compiler would throw an error. We'll see an example of that in a few minutes. Now it turns out that, let's say I do want to use cout without having to type this std:\: prefix. one thing I can do is I can use this little incantation here using namespace std. And that just means open up the namespace std, which includes a whole bunch of other things. And now I can just write cout, and then these two left brackets, and then the code that I want to write. Now the two left brackets thing, that's kind of weird. We'll talk about it. It's an instance of something called operator overloading in C++. We'll talk about that more during class. Right now, don't worry about it too much. It does look a little bit magical, and this was one of the things that I had the toughest time with when I was starting to learn C++. Right, so this is an example of showing how if we don't have that /n character at the end of cout, it's not going to print a new line. All right, so a new line is something that says advance the cursor to the next line. It's meant to be reminiscent of when we actually were printing to teletype terminals or basically printer-based terminals. New line would basically move the computer's or the printer's actual signal down to the next line. So it turns out that in the std namespace, there's also this variable named indl, which is going to stand in for this new line character. And because different machines represent new lines slightly differently, although the vast majority of them these days now just use this /n prefix, but DOS uses, for example, /n/c to indicate carriage returns, I can use this std :indl variable, which is just going to take the place of the new line. All right. Now you might notice that the main function here takes two arguments. All right. The first argument is argc, and it's declared as an integer. All right. Now, every program written in C++ needs to have a main function. That's where the program starts. This is just it can't be renamed. It always has to be named main, and it always have to have either these two arguments or no arguments. It turns out if you leave the arguments out, the compiler will just put them in for you and not show you them. All right. So we're saying we got two arguments. Argc, it's an integer, and then char *argv. Turns out that that's actually an array of strings. So it's a pointer to pointers of strings. Now, we aren't going to talk about that in this video lecture. We'll learn more about pointers and strings in class. But it's just helpful to know that whenever you type out arguments to functions, they have to have their variables declared. So it's not like Python where you can just leave off the types. You need to have the types declared. All right, so now let's do another one where we just print out cout, the program has, and then argc, arguments. All right, so let's see what happens when we run this program. All right, so we're going to say compile this program again. All right. We're going to run it, and we're going to say, well, it was given one argument. And we can see if we give it some parameters on the command line, then we'll have two arguments. Turns out that by default, the program always has at least one argument. And that's because the first argument given to the program by convention on the operating system is the program's name, which in this case would be a.out. All right, because we're always running it with this /a.out if you look on the right side of the screen. Turns out that a.out is just the default name produced by the compiler. Right, we can actually tell the compiler a name that we'd like it to use by passing this -o flag and then saying the output file we want to write. All right, so now I can run this output file. That's going to be where the compiler stores my program. Our compiler, by the way, is Clang++. It's just a nice C++ compiler based off of Clang, which is a very popular compiler now. All right, so now let's show an example of how we could create our own namespace. I'm going to type namespace and then the namespace's name, and then I'm going to put some variables inside of it. All right, and then I'm going to say, all right, this is where we're going to create our own namespace. Just like how the std namespace is defined as a standard library namespace, we can create our own namespaces. And then you would access variables in this namespace, just like how for cout you need to type std and then :cout. Now to access s or x, you'll now in the main function you'll have to type my namespace :x. All right, because it's sort of like namespaces are sort of like folders that collect all of the definitions inside them. And they're just a nicety because when you're working on really, really huge projects, you might have code written by a bunch of different people that might share some of the same names. Maybe they don't even know what they want their names to be. And so separating them into different namespaces is a really nice trick for organizing your code and keeping it really nice and separate. All right? So now we're going to write the value of x is, and then my namespace x, and then indel. All right, let's run that program and see what happens. All right, we see the value of x is 23. Now let's try this again, where we just write x, but we don't specify the namespace. Let's see what happens. All right, so this is correctly accessing it. Now I want to try an example where I just use x. I don't put the namespace up. All right, so I'm going to say this doesn't work, and then I'm going to access x, and then print the new line. And I can already tell my editor is saying that I've got an error on this line, saying that x can't be found, and that's because x is inside this my namespace namespace. Right? It's sort of like how if you move a file into another folder on your disk, even though it's got the same name, you have to specify that folder, right? So we can see that error is going to generate, and in fact, even the compiler will give us a note saying, note, x is declared here in this namespace, which is kind of a hint to you as the programmer. Ah, well, did you mean not my namespace, x? All right, so the compiler is going to try to give us a helpful note. So I'm going to comment that out just because I want to be able to compile the program and run some more examples, but I'm going to leave it in for you to see and play around with. You might uncomment it and make sure you can reproduce that same error. All right? Okay, so let's try some more things. All right, the next thing we're going to try is defining ourselves sort of a new function. All right, so functions are one of the core things in C++. I'm going to define this new function named hello world. A function needs a few things. It needs a return type, which in this case is going to be void. It needs a name, which in this case is hello world. And then it needs a set of arguments, or what I'm going to call formal parameters. And in this case, our function isn't going to have any arguments. All right, and that's because we see that open and close parentheses there. All right, so you can call this function without specifying any arguments. But in general, for example, the main function has 2 arguments. All right, now the function also needs a function definition, which is that thing between the open and closed brackets. All right, so we got a function return type, which in this case is void. And again, void is just a type in C++ that means nothing. So of course, functions that don't have any sensible return value should just have their return value being void. All right. Now, some functions will return other kinds of values. Maybe they'll return an int, for example. For example, main returns an int, and that's because main is a function called by the operating system, and its return value, the int it's returning, is then going to be used by the operating system to set that status code that we were able to check at the shell. All right. And I'm going to say that the formal arguments given in the list of arguments at the end of at the end of the line before the closed parentheses. So in this case, we don't have any arguments, but if we did have them, these arguments are called either formal parameters. Sometimes people call them formals, or sometimes people call them named arguments. All right. So now let's actually call this function, this hello world function. So to call a function, what we're going to do is we're going to write out its name, and then we're going to provide its arguments that we want to call it with. Now in this case, we don't have any arguments, so we're just going to put a open and close parentheses, and then we'll be calling the function there, just like you would in most other programming languages you've probably seen. All right, so now let's call hello world. It doesn't have a return value, so we don't need to store its return value anywhere. So let's compile that. We'll run it again, and that hello again is being printed out because we're calling hello world, and it's going to return at the end of that. Now I will point out, for void functions, we can have an explicit return. Most of the time when you return, the thing after the return is the return value from the function. But because void is a type in C++ that basically signifies nothing, we don't write anything after return. All right, so in C++ when we write return, and we don't have anything after it, that means that we had better be returning from a void function. So if we did try to return an actual value here, the compiler would yell at us, would give us a complaint. All right, now let's make ourselves another function that actually has one formal argument in. This function is going to be, it's going to declare that we have one formal parameter named in, and its type is integer. All right, so an integer is a number that can hold, positive and negative numbers. some fixed length of numbers, though. It turns out that in C++, the numbers can only be as big as the computer can hold within some number of bytes. We'll discuss this more in class. All right, so we're just going to say print out, I got the number in. Great. That's also going to be a return value. So let's actually call a function that has an actual one formal argument. All right, so now we're calling it with the actual argument 23. All right. Now let's write ourselves out another function. So now we can also define functions that, of course, just like these two functions we wrote above, these are both functions that return void. We can also, of course, write functions that have return values. So now I'm going to write a function that has an integer return value. I'm going to name that function add1. It's going to take one formal parameter x, and it's going to return x plus 1. All right. So this function does have a return value. Now let's call that function. So I'm going to say cout 1 plus 5 is, and then I'm going to call that function add1, and then its return value will be the next thing printed out. All right, so we're doing that. 1 plus 5 is, and then 6. Perfect. All right. Now we can also define arrays. So just like we can define basic types like numbers and strings and stuff, let's define ourselves an array of integers. So the way the array syntax works is that on the left I write x, int x, and then in square brackets the number of elements in the array, and then in these sort of curly brackets I write a comma-separated list of all the numbers in the array. So I'm going to compile that. I can see it compiles just fine. So now x is a variable storing an array of 5 numbers. All right, so arrays are indexed. They're sort of zero indexed. And I use this syntax, var, where var is the name of the array, and index, where index is a number, where I can index starting at 0. So let's just show a simple example of this. I can do cout, and then I can say the element, or sorry, the third element of the array x is, and then I can say x at 3. And remember, this is actually going to be that fourth number there because x is arrays are 0 indexed. All right, so I can see the third element of array x is 3. All right. Now we can assign 2 elements in an array by just writing this syntax, x at 4. So x at index 4 is going to be, let's set it equal to x at index 0. So now we're going to set the fourth element of x to be equal to the element of x at 0, which is 0. So we'll be setting that fourth element to 0. All right, the last element of x is, and then that. And then I'm just going to print this before and after so we can see that the array's value actually, or the fourth element indeed does change. All right. So let's compile that. We'll print it again. All right, great. And then let's take all of these two things. See how I duplicated code twice? Well, now what I'm going to do is I'm going to write myself a helper function so that I don't have to duplicate code. If you're duplicating code ever, it's a good sign that you should not be doing that and you should abstract out into functions. Now, when I declare arrays as arguments to functions, I'm going to use this syntax here. So this might be what you think it is. It turns out that this is actually not the right syntax. Let's see what happens when I compile this. So the C++ compiler is going to complain. It turns out that the way that I have to declare array variables is like this. I have to say, here's an array named x, and notice that C++ does not, I don't have a size after x. And that's because a function could take an array of some arbitrary size. That's kind of scary because now if I don't know how many elements are in the array, I might access a piece of that array outside of it. And in C++, it's my job to ensure that I'm getting that right, all right, as the programmer. So I'm going to also pass an explicit size variable to make sure that I'm accessing the last element of the array rather than some random piece of memory. And again, in C++, that's my job. This is one of the things that makes C++ a very unsafe language. It would be easy to just access something that looks like part of the array, but in fact is not. And then I'd be accessing just random other parts of memory. We'll talk about this more in class. All right, so I can see print last element, prints 5. I'm going to do that same thing here. That's because I don't ever like to duplicate code. If I'm duplicating code, I should abstract out and write myself a function that unifies the behavior. Right? So if you find yourself copy and pasting, you're using bad style. You should really be trying to isolate that stuff into a procedure. All right. Now notice again that when C++ passes the array x, nope, this is ignore this. This is something we'll talk about later. Silly me. It's copying a pointer, but I don't want to talk about that right now. All right. So let's go and see. Let's write a loop that goes over the array. So I'm going to introduce, obviously, so C++, like many other languages, has the construct of loops, which allow us to iterate some number of times. We just want to, in the rest of this video lecture, find the maximum element of the array. And I'm going to teach you a construct called while loops. In class, we'll also see for loops. You should read ahead in the C++ guide and also check out some of the for loops that we're going to see. All right, so now I'm going to say create myself a variable index, and I'm going to say while index is less than size. I also have to define that variable size, which I'm going to define here to be 5. I'm going to say while index is less than size, what I'm going to do is I'm going to print out that element of the array. All right, so I'm going to say we will start by just printing out each of the elements, right? And this is because when I like to develop code, I like to sort of iteratively develop and sort of build towards my solution. So I'm just going to see out the element at the array position, and then index is, and then notice how here I'm going to go to the next line because I don't like my code to overflow the end of the line. So sometimes I'll write on multiple lines. So I'm going to say the element of array position index is then, and then I'm going to print out that cout x at index. All right, and then I'm going to say index equals index plus 1, and that's because if I didn't do that, the array would just keep going around, printing out that index 0. So if I never increment x, then I'm not going to get out of this array. And there are a few ways I can do that. I can either say index equals index plus 1, index plus equals 1, or plus plus index. All of those will do the same thing. All right, and notice here that I didn't put a new line, so it's going to look really ugly. So let me go back there and add that in. All right, so now that looks good. So now I'm iterating through all the elements of the array. Let's take this code and let's actually abstract it and put it in a function, because now I've got a lot of code in main. It's going to be kind of nicer if I write a function that just says find or print and find max element. And I'm going to pass that array. I'm going to name that array R. I'm going to pass the size of the array as a parameter. All right, and the goal of this function is going to be to return the maximum element. All right. Now you can notice something funky. Print and find max currently returns void. Really needs to return an int. So let's write ourselves out some preconditions. Preconditions are things that should hold true for the programmer to call this function. So one precondition is that we need size to actually be the right size of that array ARR. And our postcondition is going to be that the return value from this function is actually the maximum element in ARR. Okay, so that's what I want. I'm going to separate these on different lines. All right. And then for now, I'm just going to return 0. This is bad behavior. It's not actually the right behavior. But when I build my programs, I like to test them as I go. All right? And testing here just means run them. We will actually write much better tests as we get towards sort of building out more interesting things in the class. Right here, I'm just sort of testing the program by running it as I develop it. But of course, that's a big no-no for sort of professional development practices. Really, I want to write nice testing infrastructure, and that's what's going to be provided to you by the projects in the labs. All right, so note here that for now this just returns the wrong value, but oh well, it'll at least print all the stuff in the array. All right, so you can see, got that here, prints. So now it just prints all of the elements in the array. The next thing I want to do is I want to actually find the maximum element. All right, and another prerequisite I might want is I might want to say, well, another precondition is that the size has to be greater than 0. All right, that's because it's kind of silly to ask for the maximum element of an array if the size is 0, because then there's no data there. So what could be the maximum of no numbers, right? So I'm just going to write a little if check here, and I'm going to say if the size is equal to 0, just return -1. Now really what I might want to do, if I were really doing this correctly, is I might want to throw an exception. Now I just don't want to talk about exceptions now, because that's a little bit complicated. So we're going to talk about those eventually, but we're not going to do that quite yet. All right, so now what I'm going to do is I'm just going to set and create a variable max. And right now, for the time being, I'm going to set it equal to the first element. And then maybe I'll do something where I index from 1. I could do that, but then the thing is it wouldn't actually loop over all the elements of the array. Right? It would index from 1 onwards. So it turns out that what I'm going to do is change that index back to 0. Then I'll print all the different indexes of the array. All right, and then what I'm going to say is I'm going to say, as I'm looping through the array, if r at index is greater than max, well, now I just want to set max to be equal to r at index. All right, so it'll update max to be whatever that new maximum element is, r at index. All right. So now I can see, of course, well, it's not doing anything useful because I'm not actually returning max. All right, so now I'm returning max. And then I'm just going to store the result of print and find max in a variable. And then I'm going to see out that variable. And I'm just going to say the maximum element is going to be whatever max is. All right. All right, and then I see the maximum number in the array is 3. All right, so great. Another thing I can do is I'm going to illustrate another one of the type things in C++ here. I can actually change this int to unsigned. Turns out there are a whole bunch of lots of integral types in C++. Unsigned int means integers that don't have any particular sign attached to them. All right, so I'm going to say unsigned 5. We'll see in class, but these integers can hold more values because they don't have a sign with them, so they can actually hold twice as many values as a regular signed int. All right, but that's just sort of an extra nuance we can learn about as we go through it. All right, so unsigned store non-negative integers, which is always what you would want an array size to be. All right, so that's pretty much it. Thanks for joining me at the first video lecture. This should be good enough to get you started and working on your first lab, Lab 0. And for that, you'll watch the companion video where you set up the auto grader. You start going through some of it yourself. Thanks.